Welcome to today's practical session. Today we're working on electricity, that is the circuit diagram, possible circuit diagram. This is resistance bus, this is the key, that the cell, the battery, this is the lamp connected to the ammeter, down to the rheostat, then to the resistance bus. They are all connected in series. In case you want to watch for mechanics, optics, and other practical sessions, that the YouTube handle, and that the number in case you want to reach me for better explanation. My name is Peter, and this is the circuit, the resistance table, the table of values rather. So if the examiner asks us to find resistances when the reading is 1 ohm, resistance is 1 ohm, 2 ohms, 3 ohms at its where in three decimal places. This is the nature of the table. We can find R square, I square, whichever one they want us to evaluate, I over R. Those ones are arithmetic values. Then we have to find the initial current when there is no resistance flowing in the circuit. But for possible precautions, we can have I ensure tight connections of wires. Then I avoided error due to power loss on the ammeter. Now let's see the circuit connection with real apparatus. So this is the connection of the circuit diagram. You have the ammeter. On the ammeter, connection is made to the rheostat. This is the rheostat. From the rheostat, you connect to the resistance bus. This resistance bus is called the uncomplicated resistance bus. It has four knobs. This is when the resistances are in unit times 1. When the resistances are in multiples of 10, you use this knob. When they're in multiples of 100, you use this knob. When they're in multiples of 1000, you use this knob. But from the table of values, our own resistances are in units, so times 1. If you need 1 ohm resistance, you just turn the knob like you are turning your radio. So 1 is pointing at this knob now, so it means 1 ohm is flowing through the circuit. Then this is the key for controlling the flow of current and the flow of voltage in the circuit. Now this is the cell. From the key you connect to the cell, from the cell you get back to the ammeter. This ammeter is a dual way ammeter. You can read for 3 ohms, 3 ampere if you connect here. If you want to read in 5 ampere, you connect to this red knob. So I'm reading with the 5 ampere. That means for easy reading, I'm using the downward value to read. That's the one that is calibrated in 0, 1, 2, 3, 4, 5. So I will not mind the upper reading. I will use the downward reading because of the nature of this ammeter is 2 in 1. So this is the from the battery you connect to the lamp. This is the lamp. You know it is the bulb, battery bulb, torchlight bulb. So it's called a lamp. So you connect from the cell to that lamp. From that same lamp, we complete the connection back to the ammeter. Now quickly, remember the reading on the ammeter is 0 because the circuit is still off. So the first thing we do is to close the circuit. In closing the circuit, you take this free end wire and connect it to the battery. So if we do that, we want to show simultaneously. You can see the pointer moved. That's the reading that is called I initial. Initial current on the ammeter when there was no resistance flowing, and that is 0.55. You can see the pointer is going to 0.6. 0 point, each calibration is 0.1, so this one is reading 0.55. So that is what we record as our I initial. Then the next thing you do is to, on that same spot, you place your bulb and see what will happen. Leave the bulb, you place it. Do you see that? So it shines. Now you watch what will happen to the intensity of this bulb as we increase the resistance of the resistant bulb from 0 to 1. So your observation will be on this intensity of the bulb and also on what will happen to the reading on the ammeter, whether it will be increasing or reducing. So we do that. Now we will take the resistance to from 0 to 1 and we watch what will happen to the intensity of this light. Right. To 1, 1, 1, 1. Yes. So at 1, you see what happened to the intensity of that light. The reading has reduced to 0.4. So we take it to 2. Yes. Yes. You can see the intensity is increasing. The current is reducing to 0.35. You can see that. So we take it to 3 ohms. You see that the intensity is increasing. Meanwhile, the current is reducing. Now it is on 0.3. When it is at 3 ohms, the current is 0.3. The intensity was increasing. Let's take it to 4. Do you see that? It's brightening up. And intensity of the current, the reading on the ammeter reduced to 0.25. Then finally we take it to 5. You see that the intensity also increased. Meanwhile, the current has reduced to 0.2. So as the resistance is increasing, the current is reducing, but the voltage that is in charge of the intensity of the light is increasing, and that is to confirm Ohm's law. As current is increasing, as current is reducing, the resistance was increasing, because the relationship between the resistance and the current is an inverse relationship. But the relationship between the voltage and the current is a direct. So as the resistance is increasing, the intensity of the light is also increasing. And that is what the examiner might ask you: why is the intensity or the brightness of the lamp increasing as the resistance is increasing? It's because of the direct relationship between resistance and the voltage. But for resistance and current, as resistance is increasing, the current was reducing. And that is all for today. So we go to the table and reflect the readings accordingly. So 0.550 ampere. We've put our values as you can see. So the examiner might ask us to plot a graph. Of course, you know, from with this relationship, you can find V. So if the examiner wants you to find V, simply multiply I by R, find your V. So you can plot a graph of, if the examiner wishes, V against I, or V against R rather, or V against I, depending on what the examiner wants you to evaluate, as the case may be. Okay, thank you for watching. Please practice for better expertise, and all will be well.